Number 14. The model below shows two continental plates. Okay, so here you have to think about our wet graham crackers. So if we dip them in water, place them on our table, and shove them together, it's going to make like different folds in the wet graham cracker. So that's going to be an example of these folded mountains. Here's our graham cracker. Here's our wet graham cracker coming together, and it's pushing up because it has nowhere else to go, right? Because the table is below it. So the folded mountains in this model form at which type of plate boundary? Well, whenever you have two of them coming together, two plates colliding, that is actually a convergent boundary. So J. Number 15. The satellite photograph below shows a large meteorite crater that is 1,200 meters in diameter and 170 meters deep. This crater is located in a flat, arid part of northeastern Arizona. How will this crater most likely change over time? So will it get deeper as it fills with water? Probably not, because Arizona is dry and arid. They don't get a whole lot of rain, so I don't know why it would fill with water. It will rise up like a volcanic crater. I don't even think that there's such thing as a volcanic crater, so I'm just going to ignore that. C, it will become less deep as the rim erodes. So right here where the rim of the crater is, you'll probably have animals coming in and out of here. You'll have wind blowing across here. So it's just going to take the dirt off the rim of the crater and probably fill it up, which is why it would become less deep. So C is like my best answer here, but I'm going to go ahead and check that letter D is not even close. So D says it will widen as it fills with lava. Well, we're in the middle of Arizona, and we're nowhere near volcanoes. So this is just a meteor crater. So this flew from space and hit Earth. So this is definitely not going to fill with lava. So C is your correct answer there. Okay, number 16. The thick black lines on the map below show the locations of mid-ocean ridges. Which geologic feature is most likely to form at a mid-ocean ridge? Okay, so let's talk about this. A mid-ocean ridge only occurs at divergent boundaries. So a divergent boundary means that the plates are moving apart, and that makes magma come up and make ridges. So your best answer choice is actually going to be G, volcano, because where magma comes up, we're just going to consider that a volcano because it's penetrating through the Earth's crust of some sort. Okay, a peninsula is like a piece of land that juts out into an ocean. So Florida, right here, would be a peninsula. Right here, south of California, is the Yucatan Peninsula. So a peninsula is not going to be a mid-ocean ridge. Deltas we've already been through. We know that that's not a delta. And plateaus are just flat plains, like flat land. So we know that that's not right. So number 16, the answer is G. Number 17, a section of a topographic map is shown below. What is the difference in elevation in meters between point X, right here, and point Y, right here on the map? Okay, so one thing I want us to know is that X is sitting at 1,600 meters. Y, that line is not identified, but the contour interval is 20 meters. So from 1,200, you would count up by 20. Because look, here's 1,200, here's 1,300. So I know I have to count up. So 1,200 plus 20 is 1,220. Plus another 20 is 1,240. So over here, I'm going to subtract 1,240 meters from 1,600 meters. So whenever you do that, okay, 0 minus 0 is 0. And then you have 0 minus 4, you can't do that. So take bar from 6, that turns 6 into a 5. 10 minus 4 is 6. And then 5 minus 2 is 3. And 1 minus 1 is 0. So you are traveling a vertical distance of 360 meters between X and Y. Number 18. The satellite image below shows a ship channel between South Padre Island and Boca Chica Beach in South Texas. So here's an island right here, and here's an island right here. Let's see if I can highlight that for you. Okay, so this is land, this is land, and that, for the most part, is land. Everything else is ocean. So this is probably South Padre, this is probably Boca Chica, or it could be the opposite, I'm not real sure. But this ship channel right here, you have the Gulf of Mexico here, and you have the ship channel right here. This means it's just an entry for ships to come and actually get all the way to the coast. Because what these islands are right here are barrier islands, so you have to get through them to actually get to the true coast of Texas. It says that sand is sometimes removed from the ship channel through a process called dredging to make it easier for ships to travel through. Recently, sand from the bottom of the channel was moved to area beaches. Without this transfer of sand, what would most likely occur in the area in the future? So dredging is like where you're just kind of taking and you're pulling, like you're cleaning out this channel and you're pulling all this sand away. Okay, you could be going either way. They could be pulling the sand this way and they're adding it to the beaches along the islands, anywhere that they can put it, just trying to keep this clear. So, if they were no longer able to dredge, what would all the sand that they're moving do? Well, would the ship channel become deeper? Probably not, because they're having to take sand out to make it deeper, so it wouldn't become deeper all on its own. So F probably is not it. The ship channel would become shallower. Well, probably because the sand would build up along the bottom of the ocean, causing it to become shallower, and then the beaches would become narrower because we are no longer adding sand to the beaches, so they would become narrower. So this looks like a pretty good possibility. The ship channel would become narrower. No, because well, possibly. They could become narrower, but the island would become completely covered with water. That's the part that really doesn't make sense, so it can't be H. And then J. The ship channel would become wider, and the island would sink into the Gulf of Mexico. Neither one of those makes sense, so it looks like G is going to be your best answer. One thing that I hope that you've noticed through these tests is that you can always do process of elimination. At least 3 of the answers always sound ridiculous. So if you can eliminate those 3 answers and just go with what's logical and common sense, you'll probably at least make a 70. So number 19, the Himalayan mountains are shown on the map below. So they're right here. 4 students were asked to identify the geologic process that caused this mountain range to form. Their responses are shown below. Student 1 says 2 continental plates are converging. Okay, well, India, we've talked about this. India is on a continental plate. China is part of the Eurasian plate. And these 2 plates are colliding, which causes mountains because they are both crystal plates. They are the same density. So think about your wet graham crackers again and how they, whenever you shove them together, they make folds just like these mountains. So student 1, 2 continental plates are converging. Yes, student 1 is correct so far. Student 2, an earthquake in a subduction zone. Well, this isn't subduction because one plate is not going underneath another because they're the same density. Number 3, a tectonic plate moving over a hot spot. Well, the only hot spots we know of are Hawaii and Yellowstone, so student 3 can't be right. And then student 4, movement at a transform fault boundary. We know that this is not a transform fault boundary because mountains are not formed at transform boundaries, and mountains are not faults, so student 4 is not correct. So, which student correctly identified the geologic process that formed the Himalayan mountains? Looks like student 1, so we're going to go ahead and circle A. Number 20. The image shows a plate boundary. Arrows have been added to indicate the movement of the plates. So it looks like this plate is going up and this plate's kind of coming down. So whenever we have two arrows like this going side by side, we know that the plates are sliding past each other, and that is a transform boundary. Because remember, convergent collide, divergent divide, and transform slide, and then you dab. So wet plate boundary feature is also shown. So do transform boundaries form ridges, valleys, faults, or volcanoes? Well, everything that we've talked about, we know that transform boundaries form faults. So the correct answer there is H. Number 21. The satellite photo below shows San Francisco, California, which has many miles of coastline and an inland bay. Which area of the coastline has most likely experienced the greatest effect of erosion from waves over hundreds of years? So this is going to really kind of stink to show you with a pen, but I'm going to do my best. So you have to look real closely at the satellite image. Everything that I'm drawing a line around is land. So everything to the right over here, this is all land over here. This is California. Okay, over here where it says Pacific Ocean, that's the ocean. So this is the ocean. Here's like a little channel right here. And then you have this inland bay right here. So this is all water. Everything past that line is land. Okay, so which area of the coastline has most likely experienced the greatest effect of erosion from waves over hundreds of years? Well, let's look at the points. T is not even close to any water, so it's not T. P is also not close to any of the water. N is pointing to this little circle dilly right there, which is not even close to the water. But then you have S right here, which is closest to the Pacific Ocean. You know that the ocean has waves, and it's actually the waves causing this little channel right here, which has allowed for the Pacific Ocean water to create this inland bay. So at point S, this is where the waves have eroded the most. So the correct answer is C, area S. Okay, number 22. The map below shows the locations of 4 active volcanoes in the Caribbean Sea. What do these volcanoes indicate about plate tectonics in that region? So F, the volcanoes form an island arc. So y'all all know what an arc is. It's just like a curved line, indicating a converging plate boundary. G, the volcanoes form a line. Well, the volcanoes don't form a line, so I know that's wrong. H, 2 plates are moving past each other, causing faulting and magma formation. No, you can't tell that from this diagram. And then J, 2 plates are moving apart, creating new seafloor. Well, we're not creating new seafloor, we're looking at islands. So these islands are actually in the shape of an arc. It's curved. So the best answer there is going to be F. Okay, our last question. A student stands at the point marked X on the topographic map below. Here. Our contour interval is 10. Here is 0 and 100. Okay, this dark line that's halfway in between is probably going to be halfway between 0 and 100. So we're going to say X is 50. And you can even count this. So this first dark line is 0. The next one is 10, 20, 30, 40. Magically X is still sitting on 50. Okay, what height in meters must the student climb in order to reach the top of the hill? Record your answer and fill in the bubbles on your answer document. Okay, so right here, we're looking for the top of the hill. Okay, the top of the hill, the highest point of the peak, is going to be 303 meters. So what we have to do here is take 303 meters, and you're going to subtract whatever point at X I'm at. So X is actually 50 meters. So 303 meters minus 50 meters. Okay, we can do this out in our heads, or we can do it the old-fashioned way. So 3 minus 0 is 3. 0 minus 5 you can't do, so you borrow from the 3. You have 10 minus 5 is 5. And then you have 2 minus 0 is 2. So you have 253 meters to climb from point X to the top of the mountain. Alright guys, so this concludes our corrections for the test. Good luck.